Hey, BC Calculus. These are the rest of the notes for section 4.5. This is integration by substitution, and so we're picking up exactly where I left off last time. So for some integrals, you can't do Lindstrom. You've got to use substitution, and it's a little more complex. But we'll show you what's going on here. So you take a look at this one here, and you go, well, where's the substitution thing going to happen? Because when I do du, that's not going to take care of the x that's sitting out there. I can make u equal to 2x plus 1, and that's exactly what we're going to do, even though it looks like it's not going to be helpful. And so then we can also say that, and I'm going to leave a little space right there. I'm going to say du is 2 dx. I know that that's what you'd expect. You're wondering why I left the space there, and I'll show you. So it's like, okay, so that takes care of that, and that takes care of that, and there's a constant in there, but I can handle that. That's not a problem. I can just say like dx, whoa, sorry, I'm moving around a lot, dx, come back to me, we're not working right now. Let's try it again. Dx, there we go, equals 1/2 du. So, we can take care of those things. What about that x in front? Well, I can still use the substitution to do that. I can solve for x in this. So move the 1 over, u minus 1 with a 1/2 would be x. So I can substitute for that also. Let's do all that. So it's the integral of, so the x becomes 1/2 u minus 1, and the square root 2x plus 1 becomes square root of u, and the dx becomes 1/2 du. Now you might be like, okay, that didn't really help us out, because now I've got two things still. I've got this and I've got this, so I still have those product rule problems, and so I'm kind of stuck and I don't have anything to do. Well, you actually do have something you can do here. Are you going to let me erase? The pen's been acting up lately. Not very happy about that. Let me move the 2 1/2s in front, make it a 1/4 constant multiplier. And so the thing is, that's a u to the 1/2 I have right here with the square root, and I can distribute that across the binomial next to it. So I can multiply this times u and get u to the 3/2, multiply it times the minus 1 and make it minus u to the 1/2 du. And see, that's the thing, is by substituting that way, I can integrate this. The big thing is I could distribute the square root u across this, but I couldn't distribute the x across the square root. So that was the difference, and that's why this is actually going to work out. And so now we're set to go. 1/4, and so it's what? So, and it's u to the 5/2 with a 2/5 in front, minus, and a u to the 3/2 with a 2/3 in front, plus c. You might say, shouldn't that plus c also be times the 1/4? And it's like, well, then that'll make it a new constant. There's still a constant at the end of it. It doesn't really matter. And so then I can multiply it out. So just to make it nice. So let's see, it's 1/10, and let's get the u out of there. 1/10, 2x plus 1 to the 5/2 minus, looks like 1/6 to me if I'm doing my fractions right, and it's 2x plus 1 to the 3/2 plus c. Boom. So you can see this was not a Lindstrom situation, because it didn't have the nice, what is that thing? Let's get rid of that thing. It doesn't have the nice, didn't have the nice, where you had an inside and a derivative of the inside or something close to it. That's not the situation here, but the substitution still works out. On a problem like this on the AP, typically they'll say use this substitution, and then you're expected to be able to work it out. Not too often do you have to do all the figuring out on your own. You can try the second one here, and it's x over square root 2x minus 1. And so take a moment and try that. You can pause it and try it yourself. See if you can find the antiderivative of this thing. Okay, now I'm going to go. So again, I'm going to do, it's the same thing. I'm going to do u equal to, u equal to 2x minus 1. And so du is 2 dx. This is very familiar here. And then I also have x equals, and it would be 1/2 u plus 1. Double check it. Looks good. And so I've got the x taken care of, I got the square root taken care of, I got the 1/2. I think I got everything. Okay, so let's do it. So it's the integral of that x thing, 1/2 u plus 1. And then that's what x is. And then I've got this thing, I've got u to the negative 1/2. And then I've got the dx, which is 1/2 du. And you can see how it's going to be a really similar thing. The 1/4 can go in front. And a lot of students, they'll just write the 1/4 and they'll go wah and wah, and then they'll just do the next step right now. So let's see. So that'd be u to the 1/2 plus u to the negative 1/2 integral. I haven't integrated it yet. Du. So that's going to be, so it's going to be u to the 3/2 with a 2/3, took me a second, minus u to the 1/2 with a 2/1 with a 1/4 plus c. Whoa, didn't leave myself that much room. And so 1/2, 2/3, that'd be 2/12, so that's 1/6. Yeah, 1/6 u to the 3/2 minus 1/2 u to the 1/2 plus c. I think I did that right. All right. So now just a quick comparison. See, this is the thing, is that you're sometimes going to have to figure out what you need to do on a problem, and you're going to have to diagnose it. And so the question is, how is this going to be different? And it's going to be substantially different. This has a 2 on top instead of the x. So in this one, I'd look at it and go, ooh, okay, that's actually the derivative of what's inside, like perfectly. So I can totally spot the Lindstrom effect here. This is the integral of 2, and then I'll write 2x minus 1 to the negative 1/2 dx. And so I've got the derivative of what's inside there, so make it go away and just do the antiderivative of the outside. 2x minus 1 to the 1/2 with a 2/1 plus c. Right? Do the derivative, multiply down, cancel out, drop the exponent by 1, that times the derivative of what's inside, that would give me the 2. Looks great. I was just double checking it, doing a quick mental derivative to make sure it worked. Now, doing u substitution on a definite integral is pretty similar, but it gets a little bit complicated here. So, so this is gonna be kind of a similar one here. That's okay. So this is another one. You can see that we got the same problem here, except it doesn't have the 2, so it won't be too bad. And so we're going to do a u substitution. We're going to do u equal to x plus 1. And what's different about this one is we've got definite integral now. Okay. And so x equals u minus 1 for that substitution, and du is just equal to dx. Okay, this is working good. This is working good. And so it's the integral of, and then the x becomes a u minus 1. And then the u becomes x plus 1, or the x plus 1 becomes a u, so that's cube root of u, yeah, and dx is just a u, so du. But now I got a little problem. I'm having the bounds go from 0 to 7, right? But that's from x equals 0 to x equals 7. That's not u equals 0 to u equals 7, that's x equals 0 to x equals 7. When I switch my variable now, I got to think about that. So one thing we can do, there's 2 ways to approach this. One way we can do it is we can just say, well, let's just work out the antiderivative, and then we'll switch it back to x's. Totally legitimate. So method number 1 is, I'm not going to put any bounds on that because it's not from 0 to 7, it's something else. But I'm going to work out what the antiderivative is, and that's just going to help me out because I don't know the antiderivative here. All right, so it's, let's see, so multiply it in, so it's the integral of u to the 4/3 minus u to the 1/3 du, and so it's u to the 7/3 minus 3/7 minus u to the 4/3 with a 3/4. There we go. And I put a plus c, but we're going to switch it back to x in a second. So I mean we're going to plug in the numbers right in a second. All right, so now u is x plus 1. So now I can switch it and say, all right, I've got the antiderivative. It's 3/7 x plus 1 to the 7/3 minus 3/4, and it's x plus 1 to the 4/3, evaluated from, oh, we're in x's now? Okay, x equals 0 to x equals 7. So now we can plug them in. So let's plug in 7 first. So plug in 7, we get 8 to the 7/3. Whoa! With 3/7 minus, and put in the 7 in there. So that's 3/4, and it's 8 to the 4/3. Cool. That's the first one. Minus, now we plug in 0, and it's 3/7 times, well, 1 to the 7/3. That's just going to be 1. Minus 3/4 times 1. Yeah. But remember that this whole thing is being subtracted. Cool. 8 to the 3/7. All right. So we do cube root of 8. So that's 2. And then 2 to the 7th, which is 128. I know that one. So it's 3 times 128 over 7 minus, and then 8 to the 4/3. That's 16. So that's 3/4 times 16. Woo. Minus 3/7 plus 3/4. Get rid of the parentheses now. Now remember, if this was an actual AP problem, stop there. Don't work this out. I mean, if you have a calculator, you can do it. Not worth it. And actually, I don't have a calculator with me, and it's not worth my time. It'll take too much time on the video, so I'm going to stop right there. But you can work it out for yourselves there. I just wanted to show the fractional exponents. The other way you could do this, which is going to amount to the same amount of work, to be honest, but it's just another approach, and you need to know both approaches. Often, like, there'll be a multiple choice question where they'll ask about it. What they'll say is, instead, let's just stay in the U world. Let's just go from the X world to the U world and transfer everything into U stuff. So when I go back to my substitution I had here, I say U is equal to X plus 1. So we start with X is equal to 0. When X equals 0, U is X plus 1, so U is 1. When X equals 7, plug in 7 for X, and you get that U equals 8. So I could have, let's do it here. Option 2. I could have said this is the integral of U to the 4/3 minus U to the 1/3 du. Just copied it. But now I'll say, oh, I know what the bounds are. The bounds are from U equal to 1 to U equal to 8. And when you look at it, you're going to see it's the same exact thing. It's just two different ways to look at it. U to the 7/3, 3/7, minus U to the 4/3, 3/4. And all of that evaluated from U equal 1 to U equals 8. And you can see that that'll get you the exact same thing. And you might say, well, if it's my choice, why do I have to know both? Because what they might do is they might ask a multiple choice question. What they want to make sure that people understand that when you change the variables, that the bounds won't work anymore. What they really don't want is that you would take the answer here and plug in 0 to 7 still, showing that you still are plugging the X values when you'd have to plug in the U values instead. So just be familiar with both. If you're just asked to do it whatever way you want to. There's a pretty good chance you might be asked to do a substitution, and then it'd be like multiple choice, and you have to pick the right one based on changing the variable and changing the bounds. So you'll see something like this. Okay. Lastly, we're going to take a look at these problems, but I think we're going to see these problems on Friday. I just want to make sure we got through the note stuff, and so we're going to take a look at this one next week on Friday in the BC class. So what did we do in this video? It was more substitution. There wasn't anything more. It was just some harder problems. We had these ones where you have to substitute, but that doesn't take care of everything, and you have to substitute in two places. So where you made U equal to 2x plus 1, but that didn't take care of everything, you had to do a second substitution to get rid of the x. Same thing happened on this one. It's just situations where you have to substitute a couple of times, and what it does is it makes the algebra work out so that it becomes something you can integrate. And then finally, we looked at this problem here where we were doing the same kind of thing, that double substitution. The only difference here was it was a definite integral, and we talked about how when you change variables from x to u, you either have to change the bounds or you have to make sure to get back to x's before you plug in those values. So you could plug in 0 and 7 with the x's, or you had to plug in 1 and 8 if you were in the U's. Okay, that's the end of the 4.5 videos. Hope this helps out, and that's the end of chapter 4. Woohoo! We'll see you soon. Take care. Have a wonderful day, and let us know if you have any questions. Bye-bye.